At post CTS, I will have hold violations.
Sir,
Yes, yes.
sir, even though at play stage, when we are checking for hold violations in
Hmm.
time decision command, it's showing hold violations also, sir, based on idle clock. Those are considerable or
Those we need not consider, right? Because
yes, sir.
once queue comes, hold, we have to again fix hold, right? So
Yes.
we need not, the primary fix for hold is addition of buffers, right?
Yes, sir.
You do not want to add buffers at play stage and then add buffers again at, post CTS stage, right?
Yes, sir.
So therefore, until queue comes up, we will not even be checking hold violations.
Okay, sir.
So at post CTS, I will have hold violations. What is the primary fix for a hold violation?
Reducing the skew value.
Reducing skew. Okay, one kind of a fix. Okay, let us say my skew is very good. I have attained whatever target skew I have mentioned. I have achieved it. In my CTS spec, I will mention the target skew. Let us say I have achieved the target skew while building CTS. What else can I do for hold fixes?
We'll go for ECO add repeaters, sir.
Yeah, we need not manually add, but yeah, the tool while fixing the hold, it will add buffers again, right? The primary fix for hold is buffer addition. Apart from skew, so the tool will again add buffers. So addition of buffers will again increase my utilization. Is that correct or no? Now from post CTS, I will go to route. Route stage, I will not touch any standard cells. Right? Only routing will take place. Routing of metal layers will take place. So what will happen? My utilization will remain same. Then from route, I will go to post route. At post route stage, again optimization will take place, wherein I will be fixing setup, hold, max strand, max cap, everything that is remaining. The only difference for previous optimization stages with post route optimization stages, now I have actual RC of the nets. Because my design is routed, previously it is estimated RC, previous to route, it is estimated RC, and after route, I will have actual RC. Again, depending on actual RC, I will again fix tran, cap, and fan out. Along with this, I will again fix setup and hold. So I will again be adding buffers, inverter pairs, etc. Right? So I expect a utilization jump at post route stage. Maybe I'll end at 75%. Right? We have started at 65% floor plan, place or place opt. Place won't change because I'm not adding anything to my netlist, or I'm not deleting any cells from my netlist. PlaySoft will add cells to my netlist. So the utilization jump is there. CTS, I will be adding clock buffers. There is utilization jump. Post CTS, I will be fixing hold and setup. Utilization jump. Route, I'm not touching my netlist, so no utilization jump. Post route, again, I'm fixing my tran, cap, fan out, setup, and hold based on actual RC. Therefore, I will again have utilization jump. Got it? Any doubts?
Sir,
Yes.
if sudden jump happen, what will happen in CTS stage?
In CTS stage, sudden jump happens. Jump, okay, jump is of what magnitude? 5%, 10%?
Like you consider 73, no? Or I will consider like 80, 85.
Okay. Post CTS, you're saying, or CTS?
Consider either in both, sir.
Okay. Place is 68, CTS is 78. What could be the issue, right?
Yes, sir.
Now you tell me. I won't answer this. Place opt is 68. CTS is 78. What will get added in CTS?
Like buffers and inverters generally we will
What buffers and inverters?
clock.
Clock buffers and inverters. Good. Because to build the clock tree, right?
Yes,
So you want to add buffers and inverters to build the clock tree. Now, more buffers and inverters got added, right? Than what is expected. Correct?
yes, sir.
Okay. So now tell me, in what case more buffers and inverters will get added?
Like
Hmm.
HFNS related.
HFNS, this is CTS.
Yeah.
HFNS is high fan out net census. CTS is clock tree census.
Okay.
What factors will the building of clock tree depend on? CTS, we will give some inputs, right?
Yes, sir.
What are the inputs that we will give?
Clock spec file.
Clock spec, correct. In clock spec, what we will give as inputs?
Like number of buffers, inverters, NDRs,
Number of buffers we won't mention, but what buffers, right?
clock. Yeah.
Yeah, so type of buffers and inverters. What else?
Mm,
It's okay, others can also answer. Today, Yashwant, Bhargavi, I haven't heard from you. Dharani,
Metal layers in which the clock nets are routed.
layers in which the clock nets are routed. Okay. Metal layers. Yeah, next.
.hdc file is also taken.
SDC file is also there. What constraints we specifically give in the spec file I'm talking about? Venkatesh,
We will give latency and skew values, sir.
great, good Chiranjeevi. Latency and skew values. What else?
India rules.
NDRs, okay, NDRs is fine. So types of buffers and inverters, metal layers, latency, skew, right? So let us take each value and see how it will affect my design. Okay, let us take each value and see how it will affect my design. I will freshly write it here. CTS. I will put latency, skew, uh, clock, metal layers I will mention. Type of buffers and inverters. These are the factors on which my CTS will depend on. All these things I will provide it to the tool. Now let us say latency. I will take two scenarios in which one I have put a latency value of 800 PS, and in the other thing I will put a latency value of 500 PS, right? Skew value in one thing I will put a skew value of let us say 50 PS or 90 PS. In the other thing I will put a value of 50 PS. Metal layers, let us say metal 8, metal 2, metal 6. Types of buffers and inverters. In this I will use a buffer 2x. In this I will use buffer 6x. Right? Inverters and buffers will be same. So now let us see how each one will affect my number of cells getting added at CTS stage. So latency, this is my design. This is my design. This is my clock port. Starting from a clock port, latency is nothing but the time it takes to reach the sync pin. Latency is nothing but the time it takes to reach my sync pin. If I say you have to reach my sync pin in 800 PS, which means I have given it a lot of time. So what it will do is it will use smaller cells, 2x buffers at a far distance, let us say 1000 microns, and it will reach my sync pin. So it is using 3 2x buffers and at a distance of 1000 microns to reach my sync pin. In the next case, I asked the tool to reach my sync pin in 500 picoseconds, which means it has to reach faster. So definitely it has to use bigger cells, 6x, and it cannot use long nets. So every 800 microns, it has to use a bigger cell, right? Let us say it used 4 6x buffers. It has used 4 6x buffers at 800 microns distance. So clearly latency of 800 PS versus latency of 500 PS. I will have more cells in 500, but you can ask me, sir, 6x can drive longer, right? 2x can drive only shorter, right? So it is a trade-off between my drive strength versus transition and load, right? Therefore, this can be one case wherein the latency difference in lower latency, while trying to meet lower latency, my tool can add more buffers. Or since 6x or 8x is higher drive strength, I will show you another case wherein the tool will add 12x, which is double of 6x, to reach the flop. Two into 12x buff. This is also 500 PS, right? So in these two cases, 500 PS. In one case, it has added 4 6x buffers. In the second case, it has added 2 into 12x buffers. Now, if my one 6x buffer is equal to half of 12x buffer in terms of area, if one 6x buffer is half of 12x buffer in terms of area, both these areas will be same. Am I right? Area in both the cases will be same, and therefore utilization will be same. If this is not the case, if area is not exactly equal, let us say 12x, area is what do you say, 5.2 micron square, whereas 6x buffer, it is 3.6 micron square. Then clearly 6x is not half of 12x, right? In that case, I have 4 into 3.6 micron square area consumed. Here 2 into 5.2 micron square. So definitely this is consuming more area and therefore more utilization. Understood or any confusion? Understood how latency affect my design utilization at CTS stage?
Yes,
Or
sir.
everyone?